So I'm going to get started. My name is Chris Hoff, and thank you for coming this morning, by the way, at 10 o'clock. I know I had trouble showing up, so I appreciate the fact that you got here at this early hour. This talk is, as you can tell, about cloud computing, and specifically is targeted towards security practitioners who are trying to get a hold or a grasp on what they have to do differently operationally, architecturally, to understand what cloud computing is going to do to what it is they do as part of their daily lives. So, the interesting notion here is that when you talk about cloud and we look at where it's evolved from, we hear an awful lot of discussions about what the mainframe models and where cloud arose from, how ultimately it's this fundamentally new technology. Some argue it's not. What's interesting about it is the elements associated with what cloud computing means to security is wide and varied depending upon which models, what you mean by cloud computing. So we're going to talk about a whole bunch of stuff in this talk, and it's really one of my kind of infotainment fire hose talks. There's a ton of content that is on these slides. I'll kind of highlight what's on the slides. You'll have them available to you. They generally end up being pretty decent reference points. The three things that we're really going to focus on here are in bold. We're going to talk about idempotent infrastructure as it relates to public infrastructures or cloud services. And I'll explain what idempotent infrastructure means in more detail, but if you start thinking about sameness of infrastructure, homogeneity from the perspective of being able to scale, that's what that's going to focus on. We're going to talk about revisiting a concept called survivability or information survivability, as well as information centricity. And these three things will kind of make more sense as we go along and discuss how cloud computing is really bringing back a lot of concepts that, in many cases, we've I don't want to say abandoned, but we've kind of forgotten. So we're going to talk about the fact that not all public infrastructure as a service providers and services are created equal, and they're not all really focused or targeted the same type of customer either. And really there's differentiation going on based on the types of networking, connectivity, security, and a whole bunch of things that ultimately make a big difference between one infrastructure as a service cloud provider, let's say at a mass market scale, versus one that specializes in certain niches. We're going to talk about the fact that public infrastructure as a cloud services can absolutely allow you to take an application today that runs in your enterprise and be deployed just as securely or even more so than what you do today. That's a tough thing to get your arm around. However, that needs to be paired with a sentence that if you are willing to fundamentally re-architect your applications, your infrastructure, your operations, your organization, and how much money you spend, where, why, and how, then that statement holds true. So we're going to talk about that. Ultimately, it really is time to kind of get the bell-bottoms out of the closet. Like every 15 years, stuff comes back into popularity, and this is one of those things. We're going to see a whole lot of applicability of stuff that has lingered around for a while, but was solutions looking for problems. Today, we have those problems. And speaking of that, this is really kind of one of a series. This is kind of the fourth in a series. I started this with my 4 Horsemen of the Virtualization Security Apocalypse talk, which talked about how virtualization was really impacting networking and security. That went on to this the Frogs Who Desired a King talk, which really kind of outlined the high-level kind of 30,000-foot view issues associated with how cloud was fundamentally changing what we did in security. And then the Cloud of Fornication talk, which was really highlighting how infrastructure kind of hot cloud on cloud action, how essentially you were getting clouds based on clouds based on clouds with staggering amounts of interdependency. So this last one is really more about, okay, we know what the problems are, what can we do about them? Where are we trending in terms of infrastructure as a service? While we have platform as a service and software as a service also, I find that in many cases people are really trying to grapple with what the differences are between infrastructure as a service and what they do in the enterprise today. So we're going to focus on that. So like most good things in life, you can blame the French. You got food and wine and, well, other things. But the point here is I like to make analogies that kind of stick with people. And maybe this one will, maybe it won't. But for me, I really like siege warfare. And I love kind of being a history of military. And so being a history buff from the military. And so from the perspective of what of siege warfare and why this relates, the trebuchet was a really interesting evolution of a set of capabilities for siege warfare that I find very interesting. You had actually not the French to blame initially, but the French and the Greeks and Romans who also stole some stuff from other people. But you had stuff like the catapult, a pretty simple mechanical fulcrum arm, and the ballista, which just launched these big spears. But then the trebuchet came online with this kind of really interesting counterbalanced weight and this sling. And what was interesting about it was the French introduced this around the 12th century, and what they really did was just better the concepts associated with what they saw in the ballista and the catapult. So as I mentioned, the trebuchet, that thing on the left, utilized this sling with this counterbalanced arm with a weight, and it basically doubled the throwing power of the engine that you could use to hoist projectiles. So catapults are really efficient. You could use them to kind of lob things like at 50, 60 pounds, a couple hundred feet. But what you found with the trebuchet is you could throw objects like 300 pounds, several hundred feet. So instead of making like little dinks in the side of a castle and kind of chipping away at it, you could knock down entire walls, right? Which is a very, very interesting tipping point from the perspective of what siege warfare and battle warfare and battlements had to deal with. So what that really amounted to was a better mousetrap, but a much more operationally complex model to deal with. And I say that because if you look at kind of how this thing is constructed, you had to have an understanding of a great deal more of physics and physical science to pull this thing off. It was really a marriage of a lot of other previous catapult designs, but with better physics and better applied physical science. And it works on a simple principle. But ultimately, there was absolutely nothing simple about getting one of the things set up, making it work, and making it work efficiently. And in fact, when things didn't work efficiently, it was horrific. So precision was a very important part about the trebuchet. And more interestingly enough, what does this have to do with cloud? Well, strangely enough, it was kind of, when you look at the trebuchet, it was an evolutionary application of some revolutionary ideas, like gravity, right? It caused quite a stir and a wholesale shift in strategy. No longer could you just expect that your castle was going to stand there and you could withstand bombardment. It really laid the foundation for a whole lot more of the mechanized sets of siege warfare applications, and even more innovation in battlefield. In the battlefield, and basically it was the precursor to a lot of how people were thinking about battlefield automation and what a defender would also have to do to deal with this. So when you think about kind of the progression there as an analogy, which I find useful in talks like this, there was a set of studies in the late 80s, early 90s from Carnegie Mellon that was funded by DARPA that was called the Information Survivability, and it talked about a bunch of shifts. And these shifts, if you think of 2000, 2001, and you think about where we are now in 2010, it may not seem like an awful lot of time, but these shifts were pretty prescient. They were amazingly accurate and very interesting when we look at how IT, if you kind of compare that analogy to the trebuchet, has also progressed. So what they said was there were 7 shifts that we ultimately were moving from a very centralized to globalized way of interacting, both from an IT perspective and way of doing business. They talked about going from bounded to unbounded. Ultimately, from insular to networked, from predictable in terms of events and timelines to asynchronous, right? From single to shared responsibility, from overhead to essential, right? From the way in which we are perceived in terms of IT, security, those sorts of things. From security to survivability, and I'll highlight what that means a little bit later. But it really is a little bit of a wholesale shift in terms of how you think about what we do. And ultimately, I added 2 more onto this. These weren't in the original 7, but from static to dynamic and from manual to automated. So if you think and you look at where we are with virtualization, you look at where we are with cloud computing, these shifts have really exactly manifested themselves in the way that Carnegie Mellon talked about was going to happen about 10 years ago. So what's actually happened is we've moved and consolidated from servers to pools of resources in terms of the compute layer. Network and storage has moved from dedicated local attached storage and disk to clusters and fabrics, both in hardware and in software. Ultimately, we have escaped from this kind of tightly coupled set of applications and infrastructure to a distributed computing model that really makes a fundamental shift in the way in which we think about both application deployment and security, and ultimately transition from infrastructure to this notion of composable service layers. And these things are interesting from cloud because if you look at at these changes and you think about where we are from a security industry perspective, we really have not addressed these moves at all, or at least not very well, right? So when you think about public cloud, Again, it's very important to think about the fact that not all public clouds are created equal or for the same purpose. That really what it talks about is, in most people's eyes, is scale that is enabled by abstracted and idempotent infrastructure, meaning homogeneity with lots and lots of it. So massive data centers with hundreds of thousands of cores, huge storage and a lot of bandwidth, ultimately. And extremely agile, heavily virtualized, and for the most part, mostly completely automated and hugely software driven, which is not really how we thought of our data centers 5 years ago. Ultimately, also, the way in which we manage and interact with these stacks is almost now moving exclusively to an API model, which means you don't have standalone apps. You can spin up and control the entire infrastructure programmatically, which is very, very interesting. So when we think about public cloud, it is important to kind of think about the enterprise version of it, just to compare and contrast. So if we think about private cloud or enterprise infrastructure as a service, it really is there to leverage virtualization, right, and basically squeeze efficiency, automation, better self-service, those sorts of things. It's really focused on security and compliance for the most part, as one big reason to keep it internally. And the infrastructure is still exposed in many cases to the IT teams. They can still, turn the knobs and twiddle the bits. It's really about the general preservation of existing architecture and infrastructure. They may converge stuff, networking, storage, and compute. It may look a little different, but the whole point is really, it's not really business as usual, but the fundamental operational practices associated with how an enterprise manages this stuff is really very similar. Public cloud, on the other side, is a fundamental re-architecture of applications, security, compliance, pretty much everything that we talk about in public cloud is about massive amounts of abstraction, meaning to isolate and hide the moving parts from you so you can get on with actually running the business instead of building the business. What's interesting here is it focuses on scale, on lower cost, homogeneity at the infrastructure layers, and is for the most part primarily software enabled or software focused. So when you think about public cloud, what this really means is it's all about gracefully giving up direct operational control over infrastructure, which is something most people are very, very uncomfortable with, especially security people, because if you can't touch it, feel it, don't understand how it works, don't have visibility or transparency, we can't do a good job of securing it. So therein lies the problem, right? What we have in public cloud is this large set of essentially heterogeneous monoculture of both operating system and hardware that is abstracted. It's the functional equivalent of what we had to deal with Siebel. If any of you, before Oracle acquired them, if you remember Siebel, you didn't change the software to fit the business. You changed the business to fit the software. Right? You had fundamental shifts in the way you were supposed to operate your business. Now, that wasn't necessarily a bad thing, but there were an awful lot of challenges associated with what was assumed we were supposed to do from a security perspective to manage this stuff. So these shifts, when we think about how we've dealt with the security models of the past, attack origin, defensive strategy, approach, how we manage identity, how we deploy applications, how hardware and software resources commingle, and where our data is, as we've kind of progressed along this timeline to the present and ultimately the future with this notion of ubiquitous cyber terror and the fact that we have reperimeterization, everything should be trending towards being information-centric, federated trust, distributed software, and cloud. What's interesting about that is when we think about how security has shifted to deal with this, to this model of survivability versus security, as I talked about before when I alluded to the fact I define it, is really about preserving operations in the face of attack. That we know we're going to get attacked, that we're going to get owned, so you have to make the systems very resilient. And it has to be holistically architected. Ultimately, it depends on the ability of these network systems to provide continuity, even if the service levels are degraded. It requires that only you protect only the critical assets, which is a really tough thing for most security folks as well as the business to understand. They expect us to protect everything equally with no budget. Ultimately, it complements the current risk assessment methodologies. It doesn't really require you to go out and make a left-hand turn to understand how risks change. But you should have a decent handle, ultimately, on understanding how these things change and impact you. It includes, but is broader than traditional information security, and we're going to get into why. So if you look at this, this came from Cisco's mid-year security report, where they kind of tracked things that are interesting, like connected devices, applications, and security threats. So we're right here, right now. 35 billion interconnected network devices on the planet. Enough for, 5 per person, right, on the entire planet. 265,000 mobile applications, 2.6 million security threats. By 2013, you can look at the number, 1 trillion interconnected devices, 140 per human being on the planet, 1.5 million mobile applications, and 5.7 million security threats. I don't know how we're going to really be able to keep up with that if we don't adjust and we don't change. So one of the things we're going to talk about here is why and what cloud does to play with this, playing this particular issue. So we're really, it should be no surprise that we've got this case of security ADD. The threat model, velocity, as well as the innovation of the attacker far outpaces the defender. We've heard that, the general said that this morning. By design, security doesn't really scale very well, right? It assumes there's going to be some human being or some level of intelligence or interaction. So automation of security doesn't really work. We don't, almost by design, allow it to, especially given how siloed we are. And that's a problem if we think about moving to infrastructure that is completely automated. It's really not about defense in depth anymore, it's about defense in width. Like, we just spray so much crap on a stack and hope that ultimately it is going to be protected that we don't know where, how, or why we invest in things. And ultimately, the economic model for vendors is not incentivized to serve or solve long-term problems. It's there to sell product based on need, and most people aren't don't have the ability to actually look downrange. They're dealing with threats today. So if we look at this ultimately, and I dragged this from my last presentation, we moved from the mainframe model where stuff was very centralized, ultimately reasonably reliable but slow connectivity to client server, skipping minis, to Web 1.0, to Web 2.0 with mashups, to kind of this emergence of this dichotomy between mobile computing and cloud computing. And at the same point in time, the security community, as well as the industry, has been remarkably consistent in its response to both programmatic development as well as how the architecture has changed. So almost consistently, we have done an excellent job of providing you one of these, which doesn't solve any of the actual long-term problems. And there's a reason for that, and that reason is called the security hamster sine wave of pain. Some of you may have seen it before, but I like to use this because it actually explains why we are where we are. We really do, on the left axis, you basically have how we invest and where we deploy from a security perspective, and we kind of flip-flop between host-based and network-based centricity for our solution sets almost constantly over time. Right? So what happens is, you can pick an arbitrary point in time on this sine wave. It's actually much more bursty, but it's smoothed and ribbed for your pleasure in this presentation. We start at hosts, right? We deploy an agent. Then we deploy 27 agents, one per threat. Then we converge those into a mega agent that takes up 86% of the CPU utilization and 14.7 gigs of memory. We say, this isn't working. So we say, what we need to do is focus on the application. We'll fix the apps. So we invest in SDLC. We basically retool the apps, and everything breaks. We deploy WAFs, and things break horrifically. And we don't know why, because the developers are completely disconnected from the security teams and the infrastructure teams. So we say, we'll focus on the information. We'll just protect it. Oh, where is it? It's everywhere. I don't know, I have no ability to essentially get my arms around the information. So we'll protect things by focusing on the user. We'll stop the monkeys from pushing the wrong buttons. And that doesn't work because people give up passwords for chocolate bars. So then we say, okay, speeds and feeds are awesome. We'll do it in the network, except we've encrypted all the data. So now I can't gain visibility without man in the middle, which breaks the applications and the users and the information. So it goes on and on and on. And to make it worse, if I overlay that sine wave with a cosine, which represents disruptive innovation or new technology like cloud or virtualization, what you find is our deployment methodology is focused up here, where the actual use case for deployment of what you're actually able to deploy from a compensated control is down here. And what I mean by that is if you look at mass market public cloud providers where the network is abstracted, I don't have access to the network, or its entire basis for what it looks like and where it is completely changes. So I can't deploy a compensated control the same way. So I have to deploy my guest. Right? So now I'm installing software instead of at 4 choke points, at potentially hundreds of thousands of endpoints that automatically scale. So what's interesting is that differential, 180 degree out of phase, is hugely problematic. Right? But we flip-flop this way, and the stuff in the middle, that information-centric part, is where we really autofocus, but we never actually get time to do that. So when we look at this problem set and we look at the stacks on the left, I like to separate things into 3 chunks. And I brought this up as a model in the Cloud of Fornication talk, and I'm going to do it again here. I like to break things down into 3 chunks. Infrastructure, which is kind of like compute, network, storage, all the moving parts. Infrastructure at the top, apps, data, metadata, and in the middle is metastructure, which is glue and guts, protocols. In a non-virtualized, non-cloud world, metastructure is supposed to bind or provide affinity between the infrastructure and the applications. It sticks them together. That's the old world model, monolithic apps. In virtualization or cloud, that middle layer, ultimately if you introduce virtualization in any concept or abstraction, is supposed to separate or provide basically a fluid layer between the two. so that they're actually not statically bound. They're separated. The problem is all the infrastructure stuff that is used to interfacing with protocols that are very stale and static completely break this model when we start to introduce mobility of workloads, of data, of information, right? So this notion of automation is really, really screwy, especially when you pair it with the fact that in public cloud providers, they're building this notion of idempotent infrastructure, where hardware, for example, and the software blends into this amorphous blob that abstracts capabilities, essentially presents you with certain layers and ways of interacting with the stack, but you don't know how they're composed. And so idempotent infrastructure is very interesting because it maps back to the root part of how our practices have to change in the security world. So when everything looks the same, it's both awesome and horrific at the same time. And we're going to talk about this. So idempotent basically is a computer science mathematic term that means essentially once I deploy, I have one system, when I deploy multiple of them, I essentially can affect an issue of scale without change. So I'm essentially able to, that you can call it multiple times and it has the same result. So when you think about infrastructure here as it relates to cloud, it means I can spin up an image or 100 of them, and essentially what I do is just serve more and greater amounts of volume. So idempotent infrastructure is interesting because when you think about it and cloud, and the Matrix is a great example with Agent Smith, right? Just keep multiplying. All the skill sets are the same, but there's just more of it. This notion is that homogeneity here provides the ability to scale out, right? Which is something, if you have the illusion of infinite scale, is awesome because you can essentially, if you have that need, continue to roll out more resources. It does not always imply commodity hardware, however. I told you that in the beginning, there's very much a difference between one extreme on the continuity scale of what public cloud providers can do and offer, and on the other end, you have people that differentiate and focus on a different set of problems. So on one side, you could use commodity hardware. On the other side, you could use best of breed. It does not always imply commodity hardware to get idempotent infrastructure. It really is there to maximize density and modularity of resources, so I can quickly reconfigure, be iteratively extensible, so I can continue to add functions. It really relies on this notion of an agile software methodology and deployment, constant deployment of software, such that it is really about being software enabled and driven, even if there's infrastructure and hardware underneath that empowers it. It's kind of this notion of code as infrastructure. And if you're a physical security, if you're a security guy that's normally used to deploying physical security, things like firewalls, where we basically just choke down on port 80, code as infrastructure should terrify you. At the same point, if you don't have those skill sets, because ultimately, how are you going to affect the ability to audit, secure, and ultimately control infrastructure that can change at moment by moment? That's not a bad thing either. And when we think about this, we get scared about this notion of elasticity, where in many cases it's not the biggest problem that we have to solve. And when I talk about that, we talk about these stacks. What's interesting today is this notion of what is powering these clouds is rapidly evolving. We've got market leaders right now that have really set the stage for the evolution of a lot of what we perceive as public cloud, but you also have a ton of movement now. You've got all of these providers, there's probably 20 more, but for example, all of these different cloud providers that have released the capability to deploy their software in any environment and build stacks and open clouds on them. So OpenStack.org is a good example. It was basically NASA and Rackspace getting together. They're open sourcing their code and making it available to deploy a cloud operating system and a cloud stack across anybody's infrastructure. You've got Cloud.com, Citrix XenCloud, a whole bunch of these available stacks. They'll ultimately consolidate, but what's interesting here is these stacks and how they function and how you interoperate and secure is pretty important. So as we're going to kind of go from the bottom of the stack up, if we look at the underlying functions that make up infrastructure, we look at the compute cores and memory elements, you've got compute fabrics now that could be commodity, they could be kind of massaged or engineered solutions, or they could be completely proprietary and specialized. You have kind of a battle raging between lots of CPUs versus fewer CPUs with lots of cores. So that's kind of an interesting thing that's occurring today. CPU versus GPU. So now you have one of the first GPU clouds being powered by NVIDIA that was, I think, released a couple of days ago for doing huge amounts of 3D rendering. Right? Very interesting. So it's not just CPUs anymore. We've seen also GPUs being used in password cracking and recovery and those sorts of things, and also by botnets.
The whole goal here is really about lower power, lower BTU output from temperature, and being highly dense. We've got interesting battles and discussions raging between vendors who support this stuff, between dedicated versus huge amounts of shared memory and allowing the hypervisors to manage its allocation. And again, everything is really here in the compute layer talked about as being managed by these RESTful HTTP APIs. So you have things like that last stack, which was Google's, a bunch of stuff strapped onto a cardboard or plastic board, with even a battery backup. You've got stuff like Cisco's UCS. You've got stuff like HP's Matrix. You've got things like the Telera, 512 cores on a single CPU. You have things like this oh man, I forget the name of the company. 512 Atom processors in a half a rack, right? Huge amounts of compute capability being squeezed into really, really small amounts of space. If we kind of go up the stack, though, and we think about all this compute node and how it's interconnected, James Hamilton, who works at Amazon Web Services, as part of a larger presentation, wrote this interesting deck that basically said data center networks are in my way. Like what I need today from a network capability in the traditional data center design is really, really stopping me from being successful in deploying cloud. So he talks about a whole bunch of stuff like I spend a lot of money, it emits a bunch of heat, I don't have the density I need, where and how I can place workloads is actually restricted, it's a mainframe business model. I think all valid points when mapped against the business model of a public cloud provider and what they do. So when you think of, let's say, a Google or an Amazon or a Facebook or even a Twitter, and you think about what they do from a load perspective and how they function and how their software is architected, what's interesting is the network architecture is very critical here, or will be and continue to be as it moves along. So these are some really, really dense slides. I'm going to kind of highlight them. But really, you have to figure out, first of all, where is the network? Is it in hardware? Is it in software? Is it a hybrid model of both? In many cases now, we have software modules, Open vSwitch, Cisco's Nexus 1000V, OpenFlow, Nicira, that really talks about these very interesting software-driven models of networking. You have to look at the fact that hugely abstracted networks really create challenges with things like network topology. Simple issues that we've dealt with before, layer 2 and layer 3, but things now that have impact on things like support for multicast and broadcast, spanning tree protocol, our understanding of how networks function. Security, how do I provide hooks to allow me to plumb in physical, virtual, or a combination of security capabilities to get me back visibility and management? The issue of mobility and the fact that as workloads move around, all of the network properties and policies and things that need to essentially be asserted by the network need to follow them. And the network needs to be able to enforce them. So naming, location, addressing, and this isn't just in a local concept, this is a much broader global concept. As these clouds get millions of cores, and they're in data centers across the entire globe, you have to figure out how your workloads and where your workloads are, and how you're going to basically make them available. This notion of performance is huge. Issues with I/O in public clouds based on that abstraction is still a huge issue. Playing packet ping pong with traffic to move it in and out of virtual machines and virtual switches to actually allow and enable it to be inspected or enforced is a huge issue. And this really brings back the issue for most people of control when they think about how they're going to interact with legacy data or even private cloud to public cloud interaction, is the revenge of the meshed overlay VPN. Essentially what you see now is this really, really high-level need for a bunch of the return of PKI to manage certificates and point-to-multipoint and multipoint-to-multipoint VPNs such that you can essentially connect resources in public cloud to those in private cloud and or business partners securely. What that brings up is the need for both physical and logical link encryption, end-to-end, authentication, tagging, and understanding that once all that stuff is encrypted, the network provider itself can't see what's in that traffic, which is both good and bad. So if we follow this along a little bit more, what this gets into is the argument between kind of big, dumb, flat layer 2 networks on one end of the extreme of the spectrum, and the need for kind of taking that next set of evolution for the classical core distribution, access, aggregation layer sets of networking. And so what that means is, what in many cases these large public cloud providers want are heavily virtualized, incredibly highly dense, very, very low latency, non-blocking line rate, 10 plus gig connectivity. So we're just getting to 10 gig, most of us in the enterprise. These guys are looking at 40, 100 gig pipes with multi-terabit switching fabrics. They control most of that stuff in software, right? With a network, they want these big, gigantic flat VLANs. Well, big, gigantic flat LANs, not even VLANs. I don't know about you, but I remember when we used to have giant, big, flat lands and the problems both from a security and performance perspective that brought. So that introduces some interesting challenges, not the least of which is this notion of full bisection bandwidth versus massively oversubscribed ports. And what that means is essentially that every port has the ability to transmit at line rate without jumping or stepping on another, which is very, very important in high-performing compute environments because latency kills when you're moving huge chunks of data, petabytes. So what these guys look for are these gigantic switching fabrics, right? But that introduces issues for an enterprise or even another cloud provider who may not need that amount of connectivity at latency issues that are an issue when they want to introduce things like segmentation. How do I deal with multi-tenancy and scale? How do I deal with things like when a lot of that networking is abstracted into the hypervisor? Do I use private or do I use VLANs, private VLANs? Do I even have a concept of what that means? How do I separate, maybe I separate control and data planes, which is a lot of what you see in the open, for example, OpenFlow switch. Very interesting stuff where you can use kind of an interaction of hybrid physical and virtual networking. So that really brings up this issue of programmable versus open and fixed versus proprietary networking stacks, which has a huge implication of what we do from a security perspective. It also brings up the issue in what we see both in the enterprise and certain cloud providers of this kind of classical data-only networking versus converging networking and data over 10 gig pipes on the same physical interface using things like data center Ethernet, fiber channel over Ethernet. So you can actually carry storage data, SAN traffic, and networking data on the same physical pipe. So if that essentially is now a single pipe, and most of our security products like firewalls have no knowledge or concept of what storage looks like in that regard, how do we actually deal with injecting compensating controls or even monitoring and providing visibility in those environments? And again, everything ends up being exposed via these interfaces for automated provisioning, orchestration, governance, APIs. These are things we're generally not used to being able to secure. Right? We can't just dump a firewall in front of this thing and expect us to add any value to this equation. So when you think about what this means to us, we have looked at what virtualization has done in the enterprise, and what it's really brought us is the fact that today, practically today, the virtual machine boundary is the new atomic unit of the data center, right? So it's really the logical perimeter that we talk about today, for now. And what that means is ultimately you're going to see the evolution of a new definition of the perimeter, but it's going to use different language, especially as infrastructure as a service bubbles up to platform as a service. So for example, Heroku doesn't talk about virtual machines. They provide Ruby on Rails capabilities hosted on top of Amazon. They talk about slugs and dynos. Anybody know what a slug or a dyno is? Most of you probably haven't heard of that. But these are new terms that denote workload and application and data content. And most of us have no idea what that means from the perspective of security, except for what we can gain from a programmatic perspective. So the cloud operating system platform networking in this particular instance has an awful lot to do when we think about where and how these VM boundaries exist in terms of our ability to enforce policy. So it determines on whether or not you get good enough or best of breed capability. It drives variability in how, what, if, or where you can even deploy compensated controls. And you have a choice now, right? Which is great, but you have a choice between much of the hamster security sine wave of pain, whether you deploy stuff at the physical, virtual, network or appliances, hypervisor or hypervisor API-enabled capabilities, whatever is exposed by the cloud provider, or in guest-based software. So, it's great to have choices, but in many cases, we don't have a lot of capability from the perspective of what's available to us from a control perspective that is available to us today that actually handles the scale, flexibility, and agility that the cloud platform itself derives. Right? So we're at the mercy of what a cloud provider gives us unless we want to continue to deal with this scale issue of deploying stuff in the guest. So when we think of storage, again, we talk about moving from local disk to SAN and NAS and object-based storage that's actually exposed via API. So you don't have logical file system units, you don't have disks, you don't have LUNs. What you have is an API you write to store data. That's kind of weird. Like, how do I secure that? How do I even know what's being used for? By the way, it can be persistent or non-persistent, which means on reboot, it can go away. Or it can remain. Depends on the service level chosen, which is very interesting too, for forensics, but also for how I protect stuff that could essentially reboot and disappear momentarily. Volume, bucket, and file size limits are different than they are in traditional storage. We have converged storage and networking. IOM performance becomes an issue when we try to add security to it. It impacts tremendously how we think about application architecture. The notion that mobility of storage itself, like you got VMs moving around, but the file systems or the storage that actually holds the data that these things boot from, that interacts with, also has to move, sometimes across data centers. So BCP, disaster recovery resilience, is very important, and ultimately and clearly isolation and security for things like forensics in multi-tenant environments are huge. Like, how do you do a memory dump on a machine that has 384 gigs of physical memory that's segmented over, I don't know, 15,000 clients, and make sense of what that means to you if you're doing forensics investigation on a particular VM in one particular spot that could move? Very, very interesting challenges from the perspective of storage. So then we kind of go up the stack to metastructure. From infrastructure, we start talking about protocols. And Van Jacobson gave this really fantastic talk. It's about an hour and a half long. You can watch it on Google Videos at this URL down below. He was talking about kind of the evolution of the internet, and I paired it well. I kind of paraphrased it for cloud, but basically he said, the cloud, or in this particular case, the evolution of networking, he was talking about it, is really like where ARPANET was yesterday. And this quote he used was, at the outset, the new network looked like an inefficient way to use the old network. And that's kind of where we are with cloud today, right? We're looking at what cloud offers, and we say, well, that doesn't make sense based on what we know of networking and security today. He said, what's interesting, when it was created, TCP/IP was not made for ubiquitous any-to-any communication. At that point, there were a couple of these giant machines sitting in these glass rooms with a couple of users with a little bit amount of data and information that would talk to each other. Right? So what was interesting was when you look at that model and where TCP has evolved, the things ultimately that people were doing with, for example, even the telco environments, making phone calls, was actually a side effect of what was done inside the network. So when we think about cloud too, what cloud does inside, the mechanical pieces of what it is able to offer, the use cases are actually the side effect of that based on how you actually design the stacks and what they're optimized for. So communications today, as Van Jacobson said, are really disseminatory. You basically say Marco, and a whole bunch of people can say Polo. You make one request, it's very asymmetric. You make one tiny HTTP request, and you get petabytes of information back if you want it, right? So it's really about disseminatory versus conversational. So the notion of locating where stuff is, naming location, and trust models are a huge issue. So when you get down to the end of it, today's networking protocol problems that we have at the metastructure layer, like DNS, like BGP, like all these things we see, coming back in style that are being attacked today, and the fixes we're putting in place, like DNSSEC, as Kaminsky's been talking about, it's really not an architectural failing. It's really actually what Van Jacobson called a success disaster, right? The side effects of what TCP/IP brought and the innovation that people use to leverage it really is a success disaster. And we're dealing with what that means because the infrastructure, again, if it was never built to do that, doesn't give us very quickly the ability to handle or secure it. So what's interesting is we kind of bubble up the stack and we think about infrastructure. This is the very interesting and fascinating part here, where architecturally, your classical n-tier design and segmentation and asset grouping methodology that you used to use may no longer apply based on how the networking and platform of the cloud provider functions. It may not make any sense whatsoever, right? There may be kind of a shadowing notion of how I divide assets into logical groups, but they don't look anything like DMZs today, especially if we think of that VM boundary that I talked about. Applications are likely not composable this way anymore because they really talk about being very distributed, as that shifts in architecture talked about. And they're becoming much, much more topologically and infrastructure insensitive than ever before, right? They want big, giant, flat layer 2 networks. In many cases, you have to completely rewrite your applications to make use of the platform in public cloud. And the security models have to change then. And so ultimately, when you look at this and you think of abstracted dumb networks, in many cases, dumb networks equals dumber security from the perspective of visibility, or at least it gives us less options in many cases until stuff catches up. So workload sensitivity, or the network being aware, the network in the sum of all its parts, being aware of what is running over it is really, really important. So people still write crappy code, so no matter how good or abstracted ultimately the infrastructure is, that's still a problem. And if you look at the fact that people continue to now adopt this notion of DevOps or agile code deployment, constant deployment methodologies, people are pushing code constantly. So how are you going to secure something with no known state that ultimately is not persistent, that doesn't survive a reboot that could change every 10 minutes? Right? How do our security models adjust? And so when we think of things, this is out of an AWS design presentation, which talked about the fact that we have a lot of decoupling here. Like if the top level were controllers, or in this case, programmatical functions, they used to be where one would call another, one would call another. Well, now we have this separated. Now we have essentially controllers talking to queues and message buses, which if you've done anything in enterprise architecture and software SOA architecture, you may be familiar with, but most of us don't think of this way. We're used to essentially deploying kind of this notion of firewalls in between these classical tiers and everything's going to be okay. Well, ultimately, now not only do I have to control the VMs, the processes, the controllers, I have to deal with securing the queue and the messaging that's used in between them, which is not a new concept, but the point here in arguing is that fundamentally the solutions aren't flawed, but the problem has radically changed, right? I made that point to Vint Cerf, and he literally kicked me in the ass. So the notion here, when we think about security models from an infrastructure as a service perspective, and we look at where the line is drawn in terms of responsibility of who does what, the lower down the stack you go, the more responsible you still are. So if you look at infrastructure as a service, right, everything above that orange line is you. You still have to do all of that regardless of the fact that you outsourced or you are giving somebody else control over the infrastructure. Platform as a service essentially moves the line up a little bit more. Software as a service, even more so. So when we think about this stack and we think about this portion to the left, since we're talking about infrastructure as a service, all of that security capability and functionality is all you. And when you think about the fact that the VMs and especially the operating system and applications are radically changing, that kind of presents a challenge. So when we think about this, there's not a whole lot you can do there at the infrastructure layer. So if we focus here, what this really means is if I have to secure the VMs or my containers, the OS and applications and my data, it really falls upon these three fundamental premises of what we're here to talk about. Building survivable systems that sustain attack regardless of what the provider themselves do, building secure applications, and securing your data. Oh, what a shocker, right? The reality is these are things that we still do regardless of the deployment methodology. So when we think about these three things, and we move up the stack to talk about what survivable systems are, it really means in many cases that if you continue to build based on what you think are relevant design patterns in the enterprise, you are certainly going to be, as I say, kind of, if your security sucks now, you'll be pleasantly surprised by the lack of change when you move to cloud, right? And that's kind of the message. When you look at that same presentation I referenced before, architecting for the cloud, here's the recommendations from Amazon, right? Design for failure. Basically what this means is cloud isn't unreliable, but the mechanisms that make up the pieces of cloud independently may be unreliable, and any piece of them can, do, and will fail at any time. So design for failure. I don't know about you, I don't get paid to design for failure. I get paid to protect based on maximum uptime, and that's kind of a disconnect. We talked about decoupling all pieces of enterprise architecture. Think about elasticity. Think about the security models. Break constraints, both programmatically, policy, from the perspective of how we actually think about design. Think in parallel. Think about different storage options. So this is advice in terms of public infrastructure as a cloud that's really targeted towards system administrators and developers. The security model elements we'll get to in a minute, but when we talk about design for failure, it means that your backup and restore strategy has to radically change. That your applications and your infrastructure has to be impervious to reboot or relaunch. That you have to think about the fact that you have to move in-memory state of applications and data to data stores. Again, storage. For persistence, you should think about, as we always should, using multiple availability zones and regions for high availability, using software-driven load balancers or hardware, depending upon the cloud provider, using relational database services that exist to essentially enable the use of elastic infrastructure in a data or database environment, and then using this notion of elastic IP, where the IP address is no longer the static constraint of where something lives or operates. So in this particular case, you may find that you are leveraging provider-specific attributes to get stuff done, even if you re-architect all the stuff, which may be fantastic if you plan to single source your provider to a single provider, no matter how resilient they are. If you want, federation, if you want interoperability and portability from a security perspective, what may work in one provider may not work in another. And this is an issue with where the arguments about the need for standards come up. Or at least a standardized way of explaining or expressing what it is we need. So I found this set of advice very interesting. I further found that last year at Source, Alex Stamos from ISEC gave a great presentation about securely moving your enterprise to the cloud. And his presentation was really good. What was interesting was he basically said what was kind of reiterating what was there in Amazon. I said, look, your current thoughts about cloud computing and security in cloud computing is missing the point that you cannot securely move into the cloud without rewriting your software. And he's talking about public cloud. That secure cloud applications really talk about collapsing the perimeter, kind of like that VM model I talked about. And that ultimately, by the time you go through this whole process, if you do it successfully, you should be quote unquote more secure. Well, I looked at these points, and he went through a whole series of illustrations, and what that really meant is, for him, summarized in these points, that you should, from a networking, from a software architecture perspective, go completely flat. That you should collapse the perimeter, use external or even internally offered glue services that allow you to dispatch and separate infrastructure from applications and use message queuing, and use a shitload of crypto. Now, this is interesting and good, except, and it sounds easy enough, but there's a big difference between greenfield applications and the legacy apps and crap and bloatware that we have to deal with in an enterprise, right? I don't have the source code. I can't rewrite Exchange. I don't have that option, right? I can't rewrite a number of legacy applications. I'm able to move them. They may not be efficient, but then if I can't leverage the elasticity and the benefits of cloud, ultimately I end up hitting roadblocks that are unintentional and not the provider's fault. It's the application architecture issues that start to preclude me from being able to do it. So because the software architecture changes dramatically, but the security models themselves do not, we have a real big problem. And we haven't learned from what we started to go down the path of service-oriented architecture, where things like XML security gateways and a whole bunch of other technology started to rear its head, but programmatically we didn't have the delivery models to actually make use of much of them. So as we move greenfield apps, which are new applications that are written specifically for cloud, that's one thing. As we move those, at the same point in time, we're really forced to think about really changing how we build survivable systems, because we can't depend on the provider. The provider does not care what's in your workload. It's not that they don't care. I say that wrong all the time. The provider, in many cases, doesn't have the visibility, and their service is not dependent upon knowing what it is you do. They're very single function. They provide you a maximally available platform to allow you to manage and deploy your virtual machines. What you transit, the data you transit with or transit in, the applications, the operating systems, are for the most part irrelevant to them. So if you can't depend on them, you've got to focus on the things that matter most, right? Surprisingly enough, securing the VMs, the apps, and the data. So when we think about this, what this means practically is that you have to assume all of the environment, every piece of the environment, including the infrastructure you're operating on, is hostile. You cannot rely on that, right? Most of us think that way, but if in the enterprise, we kind of have this implicit thing of trust. Well, we're also the single tenant in those environments. When I move to an environment that has Coke and Pepsi, or my biggest competitor, or somebody who is out to get me, that doesn't necessarily scale the same way. You have to think that this isolation in memory, in terms of tenancy, will ultimately fail. That ultimately, whatever is providing the isolation will break. And if it breaks, what does that mean to your application and data? It means focusing on GEOS, just enough operating system, not the bloatware. It means trimming this stuff down and making it incredibly more hardened than we even do it in the enterprise today, especially when we compose these differential service levels. It means investing heavily in what I call entity management, not just human to machine, but machine to machine authentication with a lot of crypto. It means ensuring robust instrumentation and telemetry at all levels of the infrastructure. Right? It means choosing open protocols and stacks so you know how they function. You have transparency and visibility, and you have options. It means leveraging introspection so you can actually see what's going on. It means selecting platforms that enable robust monitoring. Okay? And in many cases, that monitoring is on you because you don't get it from the provider. It means utilizing what is called the 3 Rs. And the 3 Rs are some of you may not have heard of before, but it's a design philosophy that goes back quite a ways. It stands for resistance, recognition, and recovery. And it's the kind of the premise of survivable systems. And what it really talks about is that, again, I'm going to deliver my essential services even under degraded performance in the face of attack. It talks about resistance, the capability to repel attack. It talks about recognition, which is the ability to detect attack and essentially evaluate the extensive damage and communicate through secure data planes the fact that this stuff is happening at all tiers. It means ultimately that we have to recover. That not only am I going to be able to serve what I serve, the most critical part of my operations and my mission, but ultimately that I can limit the extent of further damage. Right? We don't think of these terms. Right? These seem like abstract, bizarre, military jargon that has no place in our lives because we don't have the technology, we're not organized this way. The reality is cloud makes you absolutely function this way. If you are not looking at your architecture in this way, it's going to be painful. Right? So when we kind of look at what this means, we've kind of gone from the infrastructure side of the world, we've looked at kind of protocols, we've looked at the underpinnings, we've looked at what kind of survivability means at a high level. What's very interesting is this return, or this notion of information centricity in the middle of the hamster sine wave of pain. And what this really means is this kind of the center of the universe needs to return back to the thing that matters most to us anyway, which is the information. And I know this sounds like common sense and preaching, but the reality is we never get an opportunity to do this right. Cloud is that opportunity. And I implore you to kind of understand why, and how this can actually be a very good thing for us. So the Jericho Forum, almost at the same time that the folks at Carnegie Mellon started talking about their design philosophies, came up with their 10 commandments. I'm going to highlight them really quickly. It says, fundamentally, the scope and level of protection should be specific and appropriate to the asset at risk. Security mechanisms must be pervasive, simple, scalable, and easy to manage. You should assume context at your peril, meaning what works in one location may not work in another. Ultimately, devices and applications have to communicate using open, secure protocols. All devices must be capable of maintaining security policy on an untrusted network. Right? These were written before cloud came into play, but really was talking about how security has to evolve. The rest of them, all people, process, and technologies must essentially have a desired and transparent levels of trust. Mutual trust assurance has to be determinable, meaning I have to be able to understand what it is your requirements are. Authentication, authorization, and accountability must operate outside of your locus of trust and control, which means I have to be able to establish trust. Access to data should be controlled by security attributes of the data itself. It must be self-describing. And ultimately, the data privacy and security requires segregation of duties and privileges. By default, data must be appropriately secured when stored in transit and in use. And ultimately, this notion of what they call depersonalization, I think of it as repersonalization, has been in play for years. Port 80 and 443 are a perfect illustration, right? We have no real perimeters anymore. So these 10 commandments have been around since, I think this was like 2005, right, when these things were first written. And they make more sense than ever. And when we think about these requirements, it's up to you to essentially go lay smackdown on vendors to support and build products that solve these problems, instead of bringing out, necessarily, the shiniest, newest, greatest speeds and feeds of a product that isn't actually going to solve your long-term problems. So if you summarize this, information and data must be self-describing and ultimately allow it to be self-defending. The kind of Mission Impossible theme, right? This message will self-destruct in 30 seconds. Whether that data is structured or unstructured, the policies and controls must account for business context, which means we don't have to secure everything. We just need to secure the stuff that matters most. Information has to be protected as it moves between silos and in and out of these control perspectives, and the policies have to work consistently throughout various locations. And what that means is, without interoperability and portability in many cases, we're not going to be able to move that ball forward. So not only do you have to pressure security vendors, you have to pressure cloud providers to look at being able to describe and adopt standards that are open, that allow you to get solutions for which the third-party vendors can interoperate. Because it does no good to essentially say that a single source stack provider that can do all of this themselves is the only game in town, where what you actually need is the ability to move your data and content across multiple providers. So again, this comes down to threat modeling and risk assessment. It's not information alchemy. It's not rocket science. It's just a lot of crappy hard work. There's a lot of models you can use. Carnegie Mellon's Octave, RMI's FAIR, Microsoft's Stride Dread model for threat modeling. This stuff is out there. If you're not doing it already, then when you basically raise your hand saying we can't move to cloud, that's a problem, because you actually have no way of assessing or communicating why. So, the 6 key questions here are the ones you should be asking anyway for most assets. What happens if I get exposed? What does it mean to my business? What happens if could we be harmed if an employee of our cloud provider accessed the data? Would we be harmed if the process or function was manipulated, et cetera, et cetera? How do we deal with availability and resiliency issues? And the problem is, and Rich Mogan and I talk about this all the time, and I borrowed his information lifecycle model, which talks about, across the entire information lifecycle, from creation to storage to use to sharing to archival and ultimately destruction, this is a huge problem for us. We still have no real good tools, or we haven't had for a while, usable tools that allow us across this entire lifespan to essentially be able to enforce policy across the data. I mean, now we're getting applications that at the time you create data, at least structured data, you have to input metadata before you can save it, which allows you to potentially start getting a leverage point on some of this. But I added discovery because trying to find this stuff, vis-a-vis the hamster sine wave of pain, is a real problem. You need every single one of these controls to essentially affect information-centric solutions. Especially in an environment, for example, that you don't own. But in many cases, these capabilities are not present in those systems. So it's like, what do you do? We have technology today that enable you, for example, if you wanted to start rolling your own, you could do and you could use. The problem is they're nascent, they cost a lot of money, and all of the agility, cost flexibility, and issues that you get when people read page 1 of the New York Times that say you're going to save billions of dollars by moving to cloud, you have to explain why you have to go buy the equal amount of dollars to invest in new technology to secure this stuff in the first place. That being said, there's labeling technology that, based on metadata, both in use, in flight, and at rest, can use labels to identify via metadata what data there is and ultimately how it should be protected. That's available today. You have technologies that got laughed at a couple of years ago. They've been around for a while. They're starting to mature, like data leakage, data loss prevention products that are starting to make their way into cloud-based platforms, both at the guest and the network level, depending upon your cloud provider. So DLP is a component. You have a wholly unpopular term in DRM, but for an enterprise, when you start thinking about digital rights management and how you basically tell something that this piece of data can be consumed for this period of time with these particular control requirements. EDRM there are platforms, operating systems, and applications that allow you to do that. You also have huge dependency on encryption today. So when you use most public cloud providers, they provide you, for example, storage capability. If you wish for that data to be encrypted, that's on you. You have to do that. You have to engineer it, which means issues that come back to the revenge of PKI. So if you haven't been going down the path of understanding how digital certificates and encryption are going to function outside of a normal VPN, that's going to bite you. But this technology, of course, encryption has been around for a long time. But as it relates to things like row and column-based encryption in databases and applications and peering between various tiers in these distributed application environments, encryption is a huge piece of this. Right? Now we also have things like, then we have to deal with this notion of entity management and mapping that role-based and claims-based usage capability against an identity or even a machine-to-machine interaction. So identity access management, we have thousands of tools at our disposal, but again, they're not consistent. You have to roll your own. And then new things like tokenization. So for example, with PCI, this is a hot topic recently about substituting, instead of the real data, instead of storing actual credit card data, you're storing kind of tokens that represent that data. So you're not at risk, right? You're essentially of exposure of the actual raw data. You've got issues like data dispersion. So being able to chop up data streams, both in storage and in flight on the network, chop them up into individual packets, encrypt them, and then essentially make M of N number of packets reassemblable based on using encryption. So data dispersion is interesting because if you need to do things for BCPDR, or you need to make it use of essentially taking sets of network and or storage data and splitting them up so that they can't be accessed inappropriately, but then being able to recombine them on demand, data dispersion capabilities are very interesting. Mixes it into pools of streams of storage or data, but you can't essentially extract those sorts of those things holistically without being able to reassemble the keys. So stuff like this are solutions in the information-centric perspective that are available to you today. But again, if you look at this model, you have to figure out where you play and where those solutions are deployed. So if you don't demand solutions like that, or at least made available to you through APIs by your cloud provider, it's going to be real difficult for you to implement, because what that means is you're going to have to do it all on the guest, right? Which is incredibly costly, and that doesn't scale very well. So where does this take us? We need content analysis fully integrated in both productivity and what Rich calls transaction applications, as well as data stores. The rights have to be basically sprayed across these stacks, and the VMs at a very minimum have to describe what they need at the point of creation. The interesting thing, I was listening to the general of this keynote, this notion of choke points between kind of on-premise, off-premise, as well as application tiers or at the application VMs themselves, need to essentially enforce policies at the data level, not just at the VM level, right? We have to become information-centric, enforced by encryption and DRM. The rights transfer has to be able to move, because I need somebody else to make secondary reuse of that data and maintain it between state changes. You should not expect for quite a while most public cloud providers to do this for you. As I explained, they're mostly blind to your data, or at least should be. Right? That's what most people want. So a lot of it is on you, which is an issue. So are we there yet? Not quite. Right? This is very much a Lego blocks problem. So in the last minute or so, as I wrap up here, you're already here. Cloud computing is already happening. Will all your applications move to cloud computing, public cloud computing? Probably not, or at least not for a long time, which gives you the ability internally, if you start building and leveraging private clouds, to start getting a hold on being able to deploy technologies that work for you today. So we have to start thinking about fundamental changes in architecture, in programmatic management and security architectures that essentially wrap into this. We have to start thinking about centers of data, not data centers. It's kind of a funny little play on words, but it really means we have to build these survivable systems, and we have to start working on requiring vendors and cloud providers to give us visibility and transparency back to this data. The policies have to travel with the data and applications. Without that, it's useless. Ultimately, we have to allow the infrastructure to at least be made via telemetry, gain visibility and context through standards-based telemetry capabilities, right, and correlation. So if you think all the things like SIEM, you think about log correlation, you think about telemetry monitoring and management, these are all things that are just as consistently reasonable and needed today. So again, the key takeaways here, when I kind of outlined the distinction between different types across the spectrum of cloud providers, they're not all created equal. They're not essentially all built for the same reason, for the same people. And differentiation is really starting to crop up between being able to expose a lot of what this networking and security capability means. Public cloud providers can allow you to deploy applications incredibly securely if you wish to embrace requiring the need to profoundly alter architectural, security, operational, and organizational changes, right? And that's a hard part for most people to get their arms around. And ultimately, you need to deal with technology and memes and topics that we have for the last 15 years kind of been banging into, wherein a lot of this technology is nascent. It was, again, solutions looking for a problem. But ultimately, we have a lot of the key technologies available to us. You need to pressure your vendors and pressure your providers to start building them into products, right? So, to use a play on words, it really does take a village here. It takes the cooperation between providers. There was a guy back in kind of Russian history. I think he was an ambassador of sort. His name was Potemkin. And Catherine the Great wanted to take a tour of her countryside because she wanted to see how awesome people thought of her. So what they did was essentially had the villagers, because it was about prosperity, she wanted to feel good about herself, they had the villagers stand up entire fake village fronts that basically gave the illusion that everything was awesome. Right, that everything was just perfect and smiley. And at this point, that's kind of where we are today with the cloud, right? We look at these shiny, awesome use cases that don't talk about the things that matter most to us, and we don't have a lot of the tools. So ultimately, do me a favor, if you want to learn more about cloud and cloud security, go to the Cloud Security Alliance, download the guidance, get a grasp on what's different and what's the same. You can participate in Cloud Security Alliance as well as Cloud Audit, which is a project that I lead that's bringing transparency and visibility into cloud providers. It gives you a lot of this capability to understand how the infrastructure that's abstracted is managed and ultimately acted upon by your providers. So thanks very much for listening. My contact info is here. I think the updated version of this, the one I just presented, will be on the DVD. If not, it'll be at my blog, and you can download it from there. So I'm actually technically out of time, but I'll be available if you have any questions, comments, and want to hurl fruit at me later. Thanks very much.